Today we are going to learn for loop. Okay, how to use a for loop. Okay, when to use a for loop. Okay, how to apply this. Okay, we are going to learn it. Now, this lecture is a very important lecture because if you don't understand loops, you can't solve problems. You can't solve what problems. I'm making very clear to you. The loops need to be understood very well. Okay, so watch carefully, solve the problem when I give. Okay, it's going to be a long session. Is going to be, if you are not able to watch in one go, it's fine. So you can hold it and you can put a pause and come later and watch, but ensure that you have studied this completely. Okay, this is my advice to you. So first is, what is a loop here? Okay, you know what is a loop? That gets repeated, right? Repeated. Okay, that's a loop. So a loop is an iterative statement. Iterative means what? It iterates. Okay. As I told you in the control structure, there is three loops we are going to learn. One is called for, other one is called while, other one is called as what? Do while. Okay. For, while, and what? Do while. Correct? Okay. Now let us see here in these cases. First we are going to see the for loop. Okay. When I will use a for loop, whenever I want to repeat a statement again and again, the first thing is I need to repeat a statement again and again. Okay. If you want to repeat a statement, you will use a loop here. Now, the next question you need to ask here in this case, this is when. Now, the next is here in this case is, whenever you want to use a loop here in this case, you need to ask a question: how many times I need to iterate the loop? How many times I need to repeat a statement? How many times? Okay, how many times I need to repeat a statement? What to repeat and how many times? These are the two things you need to remember this. Okay. Now, the structure of the for loop is going to be like this. The for loop, for, you must have in the bracket of for, you must have a two semicolons. That's compulsory, sir. The for need to attach a statement. Below you need to attach a statement. If you have a single statement, you don't need to put a brace. If you have a more than one statement inside needs to be repeated, put a brace here. If you have a single statement, you don't need a brace. If you want to repeat more than one statement, you need to put a brace. This is a statement needs to be executed. Now, in the for, I said the two semicolons are compulsory. The first semicolon, whatever you write before the first semicolon will be treated as initialization. Whatever you write before the first semicolon will be treated as initialization. Whatever you write between the two semicolon will be treated as condition. Whatever you write after the second semicolon will be called as updation. Will be called as what? An updation. Initialization, condition, updation. Okay. Whatever you write below are the statements. Next here, in this place, how the structure of the loop is going to work. Okay, what is the structure? It starts with the initialization, then it will go to condition. After the condition, if the condition is true, it will go and execute the statements. It will go and execute the statements. Okay, it doesn't go to updation first. Remember, after the statement, where it does, it after the statement, it comes to what? Updation. After the updation, again it goes back to what? Condition. Updation. If the condition is true, repeat. If the condition is false, it will skip the statements. It will skip the statements. It will come out. Okay. Remember, it starts with the initialization, then it goes to condition. After the condition, it will come and execute the statements. After the statement, it will go back to what? Updation. After the updation, again, it will go back to what? Condition. Okay. Let us see here in these cases, I want right now to print 1 to 10. 1 to what? 10. Okay. I want to print 1 to 10. What is the statement I want to repeat? Is print. I need to print a variable. The variable should be printed 10 times. Whereas the first time the variable should hold 1, second time the variable should hold what? 2. This is a statement. needs to be repeated 10 times. From where I should start counting? I should start counting from 1, initialization. Where I should stop till my I reaches 10. What is my updation? I need to increase by 1. Now I go here. I start with the initialization. I is 1. 1 is less than or equal to 10. Condition is true. Right? Till it reaches 10, I have to do, right? It starts with the 1 till it reaches what? 10 I need to do. 1 is less than or equal to 10 is condition is true. If it is true, I am going to come and print the I value. What is I value? Is 1. After printing this statement, see only one statement, I don't need a brace. If you want to put a brace, you put. I don't have a problem. After executing this statement, I go back here. My I plus plus is a post increment, doesn't matter. I became now, in this place I is 1, but when it comes here, I value is what? 2. 2 is less than or equal to 10 true, therefore it prints for me 2. 3 is less than or equal to 10 true. 4 is less than or equal to 10 true. It keeps on this till where 5, 6, 7, 8, 9 and 10. When I became 11, 11 is less than or equal to 10. Condition is what? False. I'm going to skip the statement and I'm going to come out and I'm going to, whatever I write, I want to be executed out. Got it? Okay. Remember, you must have initialization, you must have a condition, you must have a statement, you must have an updation. Now, the most important thing is your initialization is on the lower side. Therefore, you increased it. You have increased it. Therefore, your condition, you are looking for higher value. Till your lower value I becomes what? Reaches the higher value. No, sir, I want to print right now 10 to 1. What I should do? Oh, if you want to print 10 to 1, simple thing, what I'm supposed to do? Instead of your starting point should be what? 10. What is your 10 to 1? Therefore, what will do? I minus minus. What is the condition is going to be? Your condition is going to be 10 to 10? No, 10 to 1. The 1 is on the lower side. Therefore, what I write? I is greater than or equal to 1. What I do? I is 10, 10 is greater than or equal to 1, true, print. Then I plus I minus minus, I became 9, 9 is greater than or equal to 1, 8, 4, this keeps on going till 1. 1 is greater than or equal to 1 is true, then 0. 0 is greater than or equal to 1 is false. I come out. Now look at this. I am going to go. Next is here in this case is, no sir, I will not write like this. I will write I is greater than or equal to I is 10, but I will put a condition here right now. I is less than or equal to 10. What will happen? 10 is less than or equal to 10 is what? It is true. It will print the 10 for me. I minus I plus plus, I will become how much what? 11. 11 is less than or equal to 10. False will come out. No, sir, I will write this condition. Okay, you write. What will happen? Updation, I'll write it. I is 10. 10 is less than or equal to 10 is true. I'll come inside. I minus minus 9. 9 is less than or equal to 10. Yes. And 8. 8 less than or equal to, it'll keep on now. 1. 1 is less than or equal to 10 is true. 0. 0 is less than or equal to 10 is true. Minus 1 less than or equal to true. It'll keep on becoming an infinite loop here. Okay. Even though it is not an infinite here, but you will call it an infinite because in integer ranges, there's a range. It will not go beyond the range. It will be 65535. Then it will rotate back again. Okay. Therefore, here, remember, whenever you want to set, if you want to start with a higher value, you go reduce it and you what? Look for a lower value. If you want to start with a lower value, increase it and what? Look for a higher value. Okay. So let us apply this in a program first. Okay. So a lot to be learned here, but first let us practice a problem. Okay. I'm going to give a problem. You just try by yourself. Okay. So what you need to do for me right now, you need to print the ASCII value as well as ASCII character of A to Z. A to what? Z. Okay. So you need to print for A to Z. Okay. Remember, You are going to print in the same format. What is the format should be? A is 65, B is 66, C is 67, Z is what? 90. This is what I want from you. Okay. Go, pause this, try, and come back. Okay. I hope you made an effort. Okay. So let us see here in this case, I need to print for A to Z. Okay. A to Z if you want to print. Okay. Now what I should do? Where I should start with what? For my starting is what? 1. Okay. Till where? Sorry. My starting is what? Not 1. I'm sorry. My starting should be 65. My ending should be what? 90. Correct? Right? Till it become 90. And I plus increase by 1 by 1. What I should print? Simple thing. If I want to print the ASCII table, I need to print the character C. And I need to print the ASCII value T. What I should substitute in the percentage? The I. The I, 65, needs to be printed in the character form. 65 needs to be printed in the integer form. Okay. See here. I got it. Correct? No, sir, I want to put a title. ASCII table. ASCII table is a title needs to be put how many times? Only once. Okay. Whatever you want to do once, don't put it in the loop. Keep it where? Outside. Print. I'm going to put in this case ASCII table. Done. And after this, I'm going to put the next line. I put a slash in. I'm going to run the code. Yeah, I got this answer. ASCII table. No, sir, I want to print all the ASCII values. Okay, cool. So what to do? The ASCII value starts with what? 0. When it ends with what? 127. I'm going to run it again. I put it right now. I got this. Remember, every character in the 0 to 9, there is nothing there, right? Why in front of 9 there is a space came? Because it's a tab. You printed the tab. After printing the tab, you put the 9. Why after 9 there is one extra line? Because this is what? An enter key. Sorry. After 10 there is an extra line because after printing 10 you put an enter key there. Then here 11, 12 you can see that. Okay. So these are the characters. See, all have an ASCII value. You plus is 43, multiplication is 42. Everybody has what? An ASCII value. Okay. Let me see here what would have happened if I use here character value. Okay. Let's see. Use a character. What is happening? Oh, it's become an infinite loop. Why? Okay, now, why it became an infinite loop? Simple reason. What is happening for me? What is the range of character? Till minus 128 to 127, right? Now, what has happened here? After 127, you made 128. When you made 128, character cannot store what? 128. So what it converted? It converted the 128 to what? Minus 128. Therefore, it became minus 120 to less than 127. True, it came inside back again. Therefore, it became what? An infinite. How to prevent it? One is you can make integer, or you can also make it unsigned. Unsigned, what is the capacity? 0 to 255. So in this case, your problem is solved. Got it? I hope you understood this. Okay. Remember that choosing the right data type is important. Otherwise, it will land you out in a infinite loops. Okay. Loops to repeat a statement. How many times you repeat? What to repeat? You need to ask this question every time. Okay. So let's go to the next problem. Your next problem is very simple. What do you need to do? You need to print the table of the given input. What do you have to do? You have to print the table. If I give you 7, you need to print like this. 7 ones are 7. Okay, I'll make it a little bigger font for you. The input is 7 means the input is taken. If it's 7 ones are 7, 7 twos are 14, 7 threes are 21, 7 tens are what? Till 7 tens. Okay. Remember, you need to know if you want to use a loop, you need to know what is the statement needs to be repeated, how many times. In this example, I can say what is the statement needs to be repeated, the number and the counter number, the step number, and the product of the two needs to be printed 10 times 1 to 10. See, this is a number, 7 is the number. This is the counter number, 1 to 3 step numbers, and this is the product of it. Okay, stop the video, go there and solve the problem and come. So I need to take a number. Right? What I should do? Wait. I took the number. Now I need to walk 10 times only. Therefore I put for. You can also write your integer I is equal to 1 in the latest compiler allows you I is less than or equal to 10 I plus plus. Right? What the statement needs to be repeated? I have to repeat. 3 values were printed, %d. After that, I need a multiplication sign. After that, I need a %d. Then I need a equal to sign, %d. And the next line. What is the first percentage I need to print? The number. What is the second percentage I need to print? The I value. What is the third? I need to print what? N into I. Correct? I go here, I run the code, I entered 9, I got the table of 9. 9 ones are 9, 9 twos are this. Got it? Let's go to the next problem, okay? So your question is simple. I need to print all the even numbers from 1 to 50. What are the even numbers from 1 to 50? 2, 4, 6. So what do you need to do? Okay? All the even numbers from 1 to 50. Stop the video, go and solve the problem and come. So what I need to do? I need to print all the even number from 1 to 50. Done. That means I need to run the loop up to 50. What I should do? If I say right now like this, printf %d /n, what? I. Right? If you print, what will happen? Okay, it will print all the numbers 1 to 50. But what was the question? I need to print all the even numbers. Okay. Now, when I is 1, 1 is less than or equal to 50, it came and printed it. Statement got executed, right? Now, do I need to execute this when I is 1? Do I need to print this statement? No. That means this statement needs to be selected to be executed only if the I value is what? Even. So, how to write it? Select the statement. How to write it? If I mod 2 is equal to 0. I mod 2 is equal to 0 means what? The remainder is 0 means what? It is a even number. I'm going to run the code. I'm going to run this. I got all the even numbers. 2 to 4. Okay. When the I value is even, print it. Otherwise, don't print this. Okay. Now, so look at this. I could have solved this problem in another way. How? Okay. It is not necessary I need to increment every time by 1. I can increase by 2. Therefore, how will increase by 2? Don't write I plus 2. If you write I plus 2, you know what is going to happen? You will add 1 and 2. When I is 1, 1 plus 2 is 3, but it's not stored in I. Therefore, when you come here, I value is not 3. I value is 1. Therefore, what do you do? I plus equal to 2. I plus equal to 2 means I value changes for you. Okay. Oh, but it's printing all the odd numbers. But what I want to put all the even numbers. Oh, simple thing. Start with 2. Done. Okay. I could have also done this problem in another way. How? Okay, done. So you have I plus plus. You need all the even numbers from 1 to 50. That means how many even numbers are there? 25 even numbers. Therefore, I am going to run the loop up to 25 times. What I am going to do when I is 1, I want to multiply by 2. 1 into 2 is 2. 2 into 2 is 4. 3 into 2 is 6. That's it. I got another way. Got it? So these are the options that are available for you. Okay, these are the ways, different ways to solve a problem. Different ways to solve what a problem here. Okay. So let us understand the next concept. Okay. What is a concept? See. Now I have put a variable. I put a for. Okay. For I is equal to 1, I is less than or equal to 5, I fill space, right? And I have declared a variable called x. X is equal to 0. Now what I want to do, I want to find the sum of this number from 1 to 5. Therefore, what I'm going to do in this case is, if even I is 1, I come inside. What is my statement? The sum of this number. What is sum of 1 to 5 is what? 1 plus 2 plus 3 plus 4 plus 5, right? 3 plus 4 plus 5, right? So what do? You add 1 plus 2 is 3. You store in your mind. Then what do? 3 plus 3 is 6. That is stored in your mind. 6 plus 4 is what? 10. That is stored in your mind. 10 plus 5 is what? 15. That means what you do every time now? Whatever the previous value is stored in your mind, you add with the next number. Next what? Number. So how you represent your mind in programming in a variable. Variable will hold what? A single value at a time. So initially in my mind I put nothing. When I is 1, I came inside. What I'm going to do was, I'm going to add with my mind, I'm going to add what? 0. 1. 0 plus 1 is 1. I stored back in my mind. Therefore, my x became 1. Then I became 2. 2 is less than or equal to 5. What I do? 1 plus 2 is what? 3. I became 3. 3 is less than or equal to 5. 3 plus 3 is what? 6. I became 4. 4 is less than or equal to 5. 6 plus 4 is what? 10. I became 5. 5 is less than or equal to 5. 10 plus 5 is what? 15. I became 6. 6 is less than or equal to 5 is false. I came out and I am going to print. I need to print the sum how many times? Only once. Therefore, I am coming outside. Whatever you want to do once, you have to go where? Outside. Remember that. Sum is equal to percentage D. What I put what? X. I get what? The sum 15. Now, this is called successive addition. In a successive addition, what you do, you keep on adding with the previous value. Whenever you want to keep on adding with the previous value, your initial value needs to be 0. How many times it initialize? Only once. Therefore, I kept it outside, remember. If you keep it inside, what will happen? Every time x will become what? 0. And you need to add whatever was in your mind, you add with the new value. Store back in your mind again. Store back in your what? Mind again. This is a representation I made. Okay? Got it? Now, if you want to make a successive multiplication, what do? Don't make your initial value as 0, 1. Why? Because if you make it 1, 0, what will happen? 0 into anything will become what? 0. Therefore, initial value should be what? 1. Okay? With this idea, solve the problem for me. Okay? Go write a program for me to find a factorial of a number. What is the factorial of 5 is going to be? 1 into 2 into 3 into 4 into 5. What is the factorial of n is going to be? 1 into 2 into 3 into 4 into till where n is. Okay? Go ahead. Solve the problem, please. Stop the video. Go. I hope you made an effort. What I need to do? I need to find the factorial of a number. Enter a number. Correct? Scan percentage D and then. Right? Now, how many times we need to run? If you want, what is the factorial of n is? 1 into 2 into 3 into 4 into till where? N. Therefore, my starting point is 1. My ending point is n. I increase it. And I'm going to say printf the factorial is equal to. Is my output here? Percentage. Now, what I should put here now? It is what I need to do if I want to find the factor of number 1 into 2 into 3 into 4 into 5. 1 into 2 is 2, that needs to be stored in my brain. 2 into 3 is 6, that needs to be stored in my brain. 6 into 4 is what? 24, that needs to be stored in my brain. And what is there in my brain? 24 into 5 is what? 120. Therefore, I need to represent my brain. Fact, I put fact is equal to 1. Successive multiplication. What I need to do? Whatever in my brain needs to be multiplied by the next number and stored in my brain again. So in this case, I put what? The semicolon. Remember, I put the semicolon and run the code. I put factorial of 5 is 120. If I run it and put the factorial of 9 is what this. But remember, you have a capacity. Okay? If you enter a number which is above the capacity of your number, it might give you garbage value. In this case, say for side, you need to change the data type. What do I mean by this? Okay, sir, I want to find the factorial of 35. It's not coming correct. Okay, so why? Because the capacity is of integer is only 62,000 something. Therefore, now what do you do? Make it what as a double. And if you make it a double, I need to print what here. What I print what left. Right? Let us see. Even double also has a capacity, boss. Is not something that I put the factorial of 7. Sorry, I put 7. I got here 5040. I put right now the factorial of 35. It's going to be right. Okay, this goes there. Okay, this is the, you need to understand this carefully. Okay, because you need to select the right data type for right problem. Okay, come, let us solve the next problem. Next problem. What is the next problem is, you need to find, I'm going to give you two numbers. You have to keep the first number as a base, second number as a power, and you have to calculate base raised to power. Got it? If we give you 2 and 5, you need to calculate what? 2 raised to 5. Okay? What is 2 raised to 5? 2 needs to be multiplied 5 times. How do you multiply? If I give you this, you'll say 2 into 2 is 4. 4 into 2 is what? 8. 8 into 2 is what? 16. 6 into 2 is what? 32. What you did, every time you multiplied, whatever was in your brain, you multiplied with the next 2 and stored backward in your brain again. That you use next time. First time what? 1 into 2 is what? 2. 1 into 2 is what? 2. Correct? Therefore, what you do? You need to represent your brain through a variable. It's a successive multiplication. What you need to do, every time whatever your brain has, that needs to be multiplied with what? Next base, stored back in your what? Brain again. Repeat the procedure. How many times? The power times. Repeat the procedure. How many times? What? Power times. Okay. Stop the video. Go and solve the problem. I hope that you made an effort. Okay. So what is that? I need to take two numbers, base and power. What I need to do? I need to represent my brain to store the result, previous result, and multiply with the next base. That's what we said right now. So, integer result. This successive multiplication I initialize to 1. Enter the base and power. Correct? Scalar percentage d, comma what, and then and percentage d, comma and base, comma and power. What I should do? How many times I need to repeat what? 5 times. What is 5? The power times. What is the statement I need to repeat was? Whatever there in my brain needs to be multiplied with the base and stored back in my brain again. Right? This is what I need to print. Printer result equal to percentage D, comma what? Result. I solve it, I run the code, decide that 2 and 8, I got what? 256. Correct? Yeah, I entered 5 and 3, I got what? 120. Correct? Okay? Yeah. Come, let's solve the next problem. Okay? The next problem is simple for you. Okay? I'm going to input n numbers. Sir, read my very clearly. Okay? I'm going to input n numbers. How many numbers? N numbers, not one number. N numbers. N different numbers. Okay? What you need to find? You need to find the sum of them. Find the sum of the n numbers. Sir, I don't know arrays. You don't need to know arrays. You don't need to know matrix. Nothing you need to know. What you need to know, how to apply this with whatever you have learned it. Okay. What has been given? N different numbers. You need to take n different what? Numbers. What I need to find, what the sum. I need to find what the sum I need to find. Okay. You got it? Okay. First question you ask, what is a statement needs to be repeated? How many times it needs to be repeated? What is a statement needs to be repeated is, I have to take input numbers, right? N times. Every time when I take a number, next time when I come, I will lose that number. Therefore, what I need to do, I have to keep on adding in my brain. First time I entered 5, I added the 5. Next time I entered what? 7. 5 plus 2, 5 plus 7 is what? 12. Next time I entered 3, therefore 12 plus 3 become 15. So this is the way I'll keep on adding it. Okay, got it? Stop the video, solve the problem and come. I hope you made an effort. Okay, so let us see. I need to take n numbers from the user. Therefore, first of all, I need to know what is my ns. Enter the number. Enter the limit. Okay, how many numbers you want to take? Scanf percentage D, comma what, and then done. So my loop has to run these many times because I will take n numbers. Correct? Now I equal to 1, I is not equal to n, and I put I plus plus. I put right now done this. Correct? So what I'm supposed to do? I need to, what is the statement needs to be repeated? I have to repeat, take n numbers. Therefore, I put printf scan a number and x. You can create a variable x here. If you create a variable x here, this x is visible only here. It doesn't matter. If you want to keep it outside, keep it outside. Now, what I should do? Next iteration, when you come, you're going to lose x value. So, what do? You have to find the sum. The sum variable can't be kept inside because you can't create every time. It's a successive addition. Therefore, sum is equal to sum plus what I should what? X. And I'm going to, how many times I need to print the result? Only once. The sum of the numbers equal to percentage D, comma what? Sum. Over the code, and I enter the limit. Limit is, I put here 6 numbers I will enter. And numbers are 4, 2, 8, and 1, 3, 5. You got it? Yeah? Okay. So cool. Let's go and solve the next problem. Okay. If you have any question comes in your mind, please put in the comment. I will reply. Okay, I'll reply immediately. So don't worry about it. Whenever you get a doubt, you just put a comment there. I will reply to you. But only request to you, do it sincerely. Okay, don't keep on watching the video. He's not going to help you at all. You have to stop the video, solve the problem, come back, see if you are not able to solve, look at how I solved it. Otherwise, you'll say yes, yes, yes. You'll land up nowhere. You'll land up what? Nowhere. Okay? The second thing. So if you like my session, kindly share, subscribe, and like. So now let us solve one problem called Fibonacci numbers. You must be aware of this Fibonacci series. Okay. So what is a series? How to solve it? See, the Fibonacci numbers are, it starts like this: 0, 1. These are the original numbers we know. Okay. How to generate the next number is by adding 0 plus 1 is 1. By adding 1 plus 1 is we make what? 2. By adding 1 plus 2 you make what? 3. 2 plus 3 is 5. 5 plus 3 is what? 8. 8 plus 3 is what? 13. 13 plus 8 is what? 21. 21 plus this is what? 34. And then it is what? 55. It goes like this. Okay. How it generated? The current Fibonacci number is being generated by adding the previous two numbers. By adding the previous two. 21, 8 plus 13. 8, 5, 3 plus 5. 3, 1 plus 2. 1, what is that? How it is there? 0 plus 1. But 0 and 1 are the numbers which is given to me. Okay. Now, here in this place, this is denoted as Fibonacci of 0. This is Fibonacci of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. The Fibonacci series can be built in various ways using simple variables, using an array, using a function, using a matrix, all can be done. Okay. But right now we have not done anything. We know how to use a simple what? Variables. Okay. Let us analyze this problem. What is the problem? See. How did I get this number? By adding these two. Let's assume here this is my first number. This is my second number. How did I get this? The third number is by adding what? The first and the second I got. But now I want to generate this. How to generate this? By adding these two. That means what I need to do? This number should become my first. This number should become my second. And so that this number will become my third. Correct? Now, okay, how did I get this 3? By adding these two. That means if I want to add these two, and this number should become my first, this number should become my second. That means what I observe here in this place is, every time I generate a new number, I add the previous two, I generate a new number by adding the previous two, right? And then what I do here in this case is, I convert the second to first and the third to what? Second. This is what I'm doing. I convert the second to first and third to what? And I'm repeating the same procedure. How many times? If you want to generate from 0 to 55, I need to run the loop. How many times? What? 0 to 10. That is totally 11 times right now. Therefore, what is that? I need to do what? I'm supposed to generate. You can display this number first. Printf %d and what? F. After that, what I need to do? I need to generate the third number. Generate the third number. How to generate the third number? By adding the first and what? Second. After that, what you need to do? You converted the second to first. That means second value went to the first and the third value went to what? The second. This is the procedure you are repeating. How long you are repeating what in this case is what? 11 times for I0. I is less than or equal to 10. I plus plus. This is what we did. But what is my first value of f? My first value of f is 0. My first value of s is what? 1. So let us code it out. Okay, let's code this. So what are the variables needed? I need the first, which needs to be initialized to 0. Second, I need to initialize to 1. Correct. Third, how to get the third? Third was generated by adding first plus second. Right. Then what we did? Your second became first and the third became what? Second. This is a step was repeated how many times? For integer I is equal to 0, I is less than or equal to what? 10, I plus. But every time what I need to do, I'm not printing anything, but what I need to print by making this statement, by making f is equal to s, I'm going to lose what? The f value. Therefore, what I'm going to do, I'm going to print the f value first. Print f percentage d slash t. I put what, comma, what f. I put like that. There in the code. Yeah, okay, got it. No, sir. I want to make only. I want to make only the 10th Fibonacci number. Here, what is printing? It is printing all the numbers, right? Therefore, what I need to do if you want to print the 10th Fibonacci number, there's two options are there. One option, you don't need to print every time. You need to print only the 10th number, right? Therefore, I put F. If I is equal to 10, print it. That means this statement will be executed only when I is what? 10. You have to execute the statements. Without executing the statements, you can't generate the rest. But I need to print only the 10th. Correct? Other options available for you. I don't want to check every time. By this, I'm wasting my time. So what I'm going to do in this case, I can put it outside. What is that? I need to print what? F, right? Print the F option. But see what is the challenge you are going to face. Now, what is the thing is I'm going to run if I run it? Okay, it's saying 89. 89 is nothing but the 11th number. Why 11th number I got? Because you have run the loop 11 times. It's 12 times you are running. Why? Because when you are coming out of the loop, your I value is what? 11. That's the 11th number you are getting it. No, I want the 10th number. So what do you do? Run one less. Yeah? Okay, sir. So my next problem is I want to print all the Fibonacci numbers. I want to print all the Fibonacci numbers between the given range. Between the given what? Range. Let us see what do I mean by this range. Okay, this is what is given to me. I am going to run it. This is what I have Fibonacci number 0, 1, 1, 2, 3, 5, 8, 13, 21, and it goes what? 34, 55. It goes like that. Okay. So this is going to be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It goes like that. I want to generate all the Fibonacci numbers between 10 and 30. 10 and 30. That means I want to generate only 10 and 30 here, right? I don't want to generate Fibonacci numbers, okay? I'm not talking about the range, Fibonacci numbers. So in this case, what I need to do? My question to you, if I want to generate the Fibonacci numbers between the 30 to 21, do I need to generate these numbers? Do I need to generate? Yes, without generating these numbers, you can't generate this number. Correct? Now, do I need to print these numbers? No. Next is, do I need to generate these numbers? No. I don't need to generate. Forget about printing. I don't need to what? Generate. Okay. Therefore, my loop has to run. How long it has to run? Only up to what? 30. Right? But it should start running from here, start generating from here, but you don't need to print up to what? 10. My aim is to get from 10 to 30 right now. Up to 10, I don't need to print. Once you cross the 10, I need to print them. I need to what? Print them, right? Okay. So let us see here how I should solve this problem. Okay. Let's see. So now, if you look at this, this is generating what? Fibonacci number up to 10 right now. We want to generate between the two ranges. So for printf, enter the range. Correct? Scanf percentage B, what I should write what in this case, and start, comma what, and what, end. Now my question to you is simple thing to you. Now, do I need to print all the Fibonacci numbers? You said no. Correct now. I need to print only the Fibonacci numbers, which is what? Which is greater than or equal to what? Start. But where I should stop? My stopping should be where? My stopping should be not my I. My Fibonacci number reaches what? To the end. Correct? The rest of the numbers I will generate. From the beginning to the start I will generate, but I won't print. After the start I will print them. But how long I'll run my loop? Till my Fibonacci, not my I, remember, till my Fibonacci reaches what? To the end. Integer start, comma, end. I run the code. I put right now start, range is what I put here right now, 10. And I put what? 30. Let's do this. I put 13 and 21. Correct? No, sir, I want to generate all the Fibonacci numbers between 100 to what? 500. See how many numbers are there? 144. 2. Okay? You got this? Okay? Now, if you look at this, you have started an initialization. You have started a condition. You have a updation. But sir, is there any relationship exists between initialization and condition, updation and condition? No. The purpose of updation is to make the condition as false, correct? But here updation has no relationship with what a condition. Yes. So in this case, I can knock it out. I don't need it. In a for loop, the 2 semicolons are compulsory. The rest are optional. If you don't write an initialization, what will happen? Nothing will happen. It will run. If you don't write an updation, nothing will happen. It will run. But how long it will run? Till the condition fails. Correct? Condition what? Fails. Now, sir, then you'll ask a question. In this loop, there is no initialization, there is no updation, but the loop is running how? Oh, no. The initialization is here. The updation is here. The updation is where? Here. That means if you do not have an updation in that place after the second semicolon, you can have an updation inside. What is the updation? That should make the condition as false. That should change the value of the variable whose condition is what? That determines the number of iteration. Okay, that determines number of iteration. Okay, so remember that. I put right now 5. I put 50. I should get what? Yeah. Got it? Okay. So any question, please feel free to ask me. Okay. Please feel free to ask me in the comments. I'm ready to answer you anytime. Now let's learn some series. Okay. How to solve the series problems. Okay. Okay, the first, a simple series. Okay, what I need to know, I need to find the sum of 1 plus 1 upon 2 plus 1 upon 3 plus till where 1 upon n, where n is given as an input. Actually, what is existing here? Sorry. Actually, what is existing here? Actually speaking, is 1 upon 1 is existing. Right? Okay. If you remember when we talked about a loop, so we need to know what is the statement needs to be repeated, how many times, right? Now that's what we said. How many times we know? N times. Now we know what is the statement. Here I see my numerator remains 1 only. Okay. But my denominator is changing up to n. Therefore, 1 by I, where the I has to start from 1 to what? N. Correct? And to find the summation, how to find the sum? If you ask me to do it in my mind, what I do, 1 upon 1 is 1, 1 plus 1 upon 2 is what? 1 upon 2 is not 0, 1 upon 2 is 0.5. Therefore, remember, this needs to give you a 0.5 that needs to be added. 1.5, 1.5 plus 1 by 3 is 0.33, that I need 1.833, so I need to add right this, right? Therefore, this expression first of all needs to provide a double value, a fractional value. Therefore, if I want a fractional value, either 1 has to be a float or I has to be a float. Therefore, what I'm going to do in this case, I'm going to simply write 1.0 here. Correct? 1.0 by I can be an integer or a float, doesn't matter, my result is going to be a float, right? This summation I need to find. What is a summation? Summation means what I have to keep on adding with my brain. This is adding, therefore I'm going to initial value, I'm going to make it as 0, and I'm going to say s plus 1 upon I is going to be stored in what? S again. Whatever is in my brain, add with 1 upon I and store it in what? S. This statement needs to be repeated. How many times I need to repeat what? In this case, I is less than or equal to n, I plus plus. That's it. And to print how many times? Once outside. I need to initialize s to 0 how many times? Only once. Therefore, I keep it where? Outside for. Okay. So I'm going to convert this into a code here. What is the statement needs to be repeated? 1 by I needs to be added with a s right now. Therefore, my sum is going to be a float. Why? Or double. Why? Because it was a fraction. Therefore, now I can be an integer or a float, doesn't matter for me. Right. For now, I need to take an n as an input. Sorry, I need to take n as an input here. Therefore, in this case, printf, I'm going to say enter the range. Scan percentage t for I is equal to 1, I is less than or equal to n, I plus plus. Right? What we said? Whatever is in my brain has to be added with 1 upon I, needs to be stored in what? In my brain again. That needs to be added next time. This needs to be, that sum is equal to percentage what I left. I put 5. I got the answer what? 5. I can't get 5 here. Okay, now why? Because why I can't get 5? Because 1 upon 1, if I add it, it's not can't be 5. The mistake I made was I've written I here. It should be 1 upon I. Sorry. S is equal to S plus. Okay. Run. I'm going to run the code. I put 5. I got the answer what? 1. If it is 1, I'm in a problem. Why? Because what is the problem? 1 upon I you are writing. When I is 2, when I is 1, 1 upon 1 is 1. When I is 2, 1 by 2 is how much it became what? 0. Why 1 by 2 is 0? Because 1 is an integer, I is an integer. Therefore, what I'm going to do, I'm going to make it here 1.0 by I. I'm going to run the code and I'm going to 5. I got the answer what? 2. I'm going to put 3. If I put 3, I should get 1.833. Correct? Yeah? Understood what is the mistake we made? The mistake is here. Remember, when you solve this problem, the result will be stored on a register. You need to make a decision on the register. What type of register you want to store? Your S is a sum is a double. Doesn't matter because here your register is an integer. Therefore, it was not able to hold a fractional value. Okay. So let's solve the next problem. last time we found the sum of 1 plus 1 upon 2 plus 1 upon 3 plus 1 upon n. Right? Now what I want the sum of 1 plus 1 upon 2 square, 1 upon 3 square plus 1 upon n square. Okay, go make an effort, stop the video, solve the problem, and come. So if I take you try this answer. If you tried it right now, you try this answer. If my n is right now 3, if my n is 3, what is the answer? You got it. Okay, if n is 3, what's the answer? If n is 3, we got 1.83. Correct. Now here what I could answer is 1 plus 1 upon 4 is what? 0.25. 1 upon 9 would be what in this case here? 0.1 something. Therefore it should be 1.3 something you should get it. Okay. So let us see whether you are getting it or not. Okay. 1.3 something you should get it. Okay. I hope you tried it. Okay. So what is the thing you must have done? What is the difference between the last exercise and this? Here I put 2 square, 3 square, 4 square, 5 square, right? Okay. So if we know this is, I have put here right now in this place, square I have put. Okay. So how to write a square? What is nothing but I square? This is nothing but I square, right? I square is I into I. So what you must have done it also, you must have made a mistake also. You must have written 1 by I into I. When you write 1 by I into I, you know what is going to happen? It is going to divide 1 by I and the whole result is going to be multiplied by I. The reason is because it moves from left to right. Correct? Therefore, this is the one of the mistakes you must have made it. Therefore, you may not have got the answer 1.33. Let's make the mistake and see what is coming first. Okay. So let us see here in this case I put right now the same thing I put here into I. I run the code with input what? 3. My answer is coming 3 point something. But whereas it's supposed to be 1.33, right? 1.3 something, correct? The reason is this. So the bracket is important. Okay, the bracket is what? Important. I put 3 now. I got the answer 1.36. Got it? Okay. Come, let's solve the next problem. Now you need to give me the summation of sum of 1 plus 1 upon 2 factorial plus 1 upon 3 factorial till up to 1 upon n factorial. You know it well. What is here? 1 upon 1 factorial. 1 factorial is 1 only. Correct? Now, what is it? Numerator is always 1. What is the denominator? Is a factorial. That summation I need to find s plus equal to. But what is a factorial? First time it should be 1. Second time it should be what? 2 factorial. Third time it should be 3 factorial. That means every time my factorial needs to change. Okay? Go solve the problem. Try to solve the problem. If I enter my input n is 3, the answer should be 1 upon 1 is 1 plus 1 upon 2 is 0.5 and 1 upon 3 factorial is this. It's supposed to be 3 factorial. How much it is? What? 6. It's supposed to be for you 1.6 something. You should get it. Okay? Go ahead, solve the problem. So what is the difference was? What is the difference was the factorial. But the factorial should be first time 1 factorial, second time 2 factorial. Okay, simple thing. F is equal to f into I. Why? First time when I is 1, 1 into 1 is 1 factorial. When I is 2, 1 into 2 is 2 factorial. When I is 3, 2 into 3 is 6. That is 3 factorial. I'm going to get it. Okay, let's go. I'm sorry, I will declare factorial. Correct. I'm going to make it float. I'm going to make it 1. Why? Because successive multiplication, initial value has to be 1. I put this 0. I run the code. Enter the ranges. I put 3. I got the answer what? 1.6. Okay, that makes sense. Any question? Yeah? Come, let's go. See, now you need to find this series, summation of this series. As you know, this is nothing but 1 upon 1 factor. So what is there? My numerator is 1 only. But my denominator is a factorial. But the factorial has a problem. What is the problem is, right now I'm working on this. Okay, I'm not working about the sign. What is the problem I'm seeing here in this case? I need only the factorial of the odd numbers. Last time I had 1 plus 1 upon 2 factorial plus 1 upon 3 factorial plus 1 upon n factorial, right? But this time the even is being skipped. Only the odd is being added. Odd is being added. Forget about the sign right now, okay? But sir, is it possible for me to generate the 3 factorial without generating 2 factorial? No. Why? Because what is 3 factorial is 1 into 2 into 3. What is 5 factorial is 1 into 2 into 3 into 4 into 5. Therefore, I won't be able to skip the even ones. I have to generate the even ones. But what I should not do, I should not add them. Therefore, here, my every time I need to generate the factorial, my addition needs to be put a condition. When I need to add here, if my factorial is the factorial of the odd numbers, I need to add. Otherwise, I need to do generation needs to be done, but addition should be put a condition. If I is the factorial, ith factorial, I modulus 2 is not equal to 0, I need to what? Add it. Generate what? Every time, but add only what? In this case. But there is also the problem. What is the problem is, first time when I is 1, you make 1 factorial. 1 modulus 2 is not equal to 0, you added it, correct. Now when I is 2, 2 factorial, 2 modulus 2 is what? 0, you are skipping it, right? Okay, I put for you to understand. For I is equal to 1, I is less than or equal to, I don't know, right? Correct? But the problem is, when I became 2, I have not written the condition here. When I is 2, 2 factorial, 2 modulus 2 is 0, I skipped it. When I became 3, 3 factorial, 3 modulus 2 is 1, I added. But what is that? I have achieved this goal, but what happened is here, my sign is not here is positive, it is negative. See, first is positive, second is negative, third is positive, fourth is what? Negative. How to do it? Simple thing. Your numerator is first time 1, second time minus 1, third time 1. That means your numerator cannot be here a constant. It has to be a variable. Correct? What should be first time numerator? Should be 1. Numerator should be 1. But then what? Second time when I come to this statement, my numerator should become minus 1. How to convert it? Simple thing. Second time when I come, numerator is equal to minus numerator. See here I am writing inside the if. That means first time when I is 1, you added 1 factorial. 1 modulus 2 is what? Is 1. You came, you added it. 1 upon 1 factorial, added. Right? 1 upon 1 factorial, you added it. Done. Done. Now you say numerator is equal to minus numerator. That means numerator become minus 1. I became 2. 2 is less than or equal to either. F into I. That means 2 factorial. 2 modulus 2 is 0. I skipped it. Then I became 3. 3 factorial. 3 modulus 2 is 1. My numerator is minus 1. 3 factorial. Done. This has been done. Now numerator is equal to minus numerator. My numerator was minus 1. Minus of minus will become what? Plus. Next time I achieve this code. Correct? But sir, here is written not n times, is written n terms. That means if the number of terms are 3, I don't need to go up to 3 factorial. I need to go up to 5 factorial. 3 means I need to go up to what? 5 factorial. 4 means I need to go up to what? 7 factorial. How to get it? That means my iteration needs to be, if n is 1, I need to go up to what? 1 factorial. My execution is what? Up to 1 factorial. If n is 2, I need to go up to 3. If n is 3, I need to go to what? 5. Yeah? If n is 4, I need to go to 7. So what is the relationship you see? What is the relationship between n and x? It is nothing but 2 into n minus 1. 2 into n minus 1. 2 into 1 is 2, minus 1 is 1. 2 into 2 is this. 4, 4 minus 1 is 3. That means my loop has to run up to 2n minus 1. 2n minus what? Minus 1. Okay. Can we try the code? Complete the code, run the code and come. I hope you made an effort. Okay. What we said? If n is 3 means I need to go up to what? 5. Therefore, I said 2 into n minus 1. My numerator cannot be a constant. It has to be a variable because it was changing. I need to add only when I need to add. We said what? If when I mod 2 is not equal to 0, correct? And then what you do here? My numerator has to become minus numerator m. Right? These are this we said, okay? It goes up to 2n minus 1 time. Every time I need to generate the factorial, 1 factorial, 2 factorial, 3 factorial, 4 factorial, I need to generate. There's no change. But what I need to do here in this case, I need to add only when if my factorial is odd, the ith factorial is what? Odd factorial. And every time my sign changes, if I use this, sorry, I need to declare the variable numerator 1, yeah. Then I go, and the range is 3, I should get what? 0.8. Got it? Yeah. See this. The first is when you get a problem, analyze it, then come here to write the code. Yeah. If you have any queries, please ask in the comments. I'm ready to help you. Okay. Let's go to the next problem. Next problem is based on this problem only. Okay. But it will be little more. See here. We wrote sum of 1 minus 1 upon 3 factorial plus 1 upon 5 factorial minus 1 upon 7 factorial plus it goes up to n terms in part. Now what you need to do, I want to find the summation of the sine series. Sine of x is calculated as x minus x raised to 3 upon 3 factorial plus x raised to 5 upon 5 factorial minus x raised to 7 upon 7 factorial, and you need to add 10 terms. And what terms? Okay, 10 terms you need to add. Okay. What is the change I see? My denominator remains the same of the previous problem. But only I need to go up to n terms. Here n terms, I meant 10 terms. How to get 10? 10 is 10 terms means I need to go up to what? 2 into 10 minus 1, 19 times. Done. My loop has to run how many times? 19 times. Done. But here what happened? My numerator has a problem. Here x is there, x raised to 3 is there, x raised to 5 is there. My numerator is increasing itself by x raised to 2. See? Here x raised to 2. X with x into x raised to 2 is x raised to 3. X raised to 3 into x raised to 2 is what? X raised to 5. X raised to 5 into x raised to 2 is what? X raised to 7. Correct? Yeah. So every time with the previous numerator, I need to multiply what? X raised to 2. X raised to what? 2. What is the initial value of my numerator is x. What is x? X is angle in what? Radians. Angle in what? Radians. Okay. You got it? Okay. Make an effort. Go solve the problem. I hope you made an effort. Okay. Now what we said, we need to go up to, I don't need what? N. I need to go up to, because it was fixed. In order to get, the 10 terms, I need to go up to 2 raised to what? 19. That's sorry. In 19, I need to go. I put 19. Therefore, n is not needed. But what is needed right now? The x is needed. Therefore, I am going to ask the user, enter the angle in what? Radians. Oh, so he may not enter in radians, degrees. Okay. Now, I need to take the degrees. It can be anything. I'm going to safer side. I'm going to make it a float double only, and I'm going to take what? This is my x. Right? Now, what I'm supposed to do? I need to convert this into radians. How to convert? X is equal to x into 3.14 by what? 180. Right? Because all my sine, cos, everything takes angle in what? Radians, not in what? Degrees. Remember. Now what happens in x is? I'm going to put here right now. Oh, that's my. We need to have, what was the change was there? My numerator was changing. Correct now? My numerator was increasing by x raised to 2. What's the initial value of numerator? Here it is 1. Can I make the numerator equal to x here? No, don't do. Why? Because x does not have a value here. X is going to get a value only here. Therefore, what do you do? Numerator is equal to x. Right? What I'm supposed to do? First time, when I is 1, 1 factorial, 1 modulus 2 is how much it is what? 1. I added x by 1 factorial added. Numerator is equal to minus numerator. Numerator become minus x, but it should not be minus x, it's minus x cube. Okay, therefore what do you do? Simple thing. Into x into x. Minus x cube, right? Then you go, I became what? 2. 2 factorial. 2 modulus 2 is what? False. I became 3. 3 factorial. 3 modulus 2 is 1. I came here s plus numerator is what? Numerator is x raised to minus x raised to 3 by 3 factorial. Now minus numerator, that will become positive. X raised to 3 into x, that will become what? X raised to 5. Therefore, I am going to get the answer. If I assign 60, what is the answer I should get? The point. Now I need to verify this right now whether this value matches with the real sine value, which is the inbuilt one. I can verify. I should include. Okay. Math.h. Right. Then you go. Here you write here right now. What I'm going to do, I'm going to compare whether both are equal or not. So how to compare? Sum. I'm going to sine value. Sine of x is going to be equal to, this is my value. What is the sine value of that? Printf. Okay, math class math sine. X is going to be equal to percentage left. I put here right now, comma, sine of x, right? Slashing, and I put this in the degree of 60, and I got Yeah, my value and the math is both are same. Both are what same. This is the way you verify that you got the right answer or not. Got it? Yeah, cool. So let us go and solve the another problem. Okay, but this problem I want you to solve by yourself. I am not going to give a solution. You have to struggle. You need to get the answer. Same way you compare, you should get the answer. Okay. The simple is you need to find the cos of x. See, make an effort. Okay. Nothing wrong in making an effort. Okay. Cos of x is calculated like this: 1 minus x raised to 2 upon 2 factorial plus x raised to 4 upon 4 factorial minus x raised to 6 upon 6 factorial plus it goes up to what? You need to go again 10 terms you need to add. That means you need to add what here 10 terms means you need to go up to what? 20 because here is correct? Or 10 terms is x0. It starts with what? You can put the 20 or you can go to 18 times. Now this is nothing but 1 is nothing but x raised to 0 upon 0 factorial. Hmm? What is the difference between last time and this time? The last time and this time, here last time it was all odd ones you added, this time you're adding even ones. But the numerator remains the same. What is the same? That it was every time the power is increasing by what x raised to 2. But the starting here was x, but here is starting is what 1. That's it. That's the only difference you have to understand, analyze the code, analyze the problem, and solve the problem.